Artificial intelligence is absolutely everywhere, but let's be honest, the language around it can feel like a totally different world. So in this explainer, we're going to cut through all that noise and build a simple glossary for the most important AI terms you really need to know. Let's get right into it. So, if you've ever heard terms like LLM or neural network or generative AI and felt your eyes kind of glaze over, you are definitely not alone. It's a crazy fast-moving field with a ton of buzzwords. But don't worry, we're about to make it all make sense. Here's our game plan. We're going to start with the absolute basics. What even is AI? Then we'll peek under the hood to see how it learns. From there, we'll get into the power of language, then talk about how AI creates and acts on its own, and finally, we'll see where it's all popping up in the real world. A pretty straightforward journey from start to finish. All right, first up, when we say AI, what are we actually talking about? Let's lay down that foundation. At its very core, artificial intelligence, or AI, is really all about one thing: creating machines that can simulate human thinking and learning. So think about a self-driving car. It has to see the world around it, understand it, and then make decisions in real time. That's a perfect example of AI in action, trying to replicate a very, very human skill. Now, this slide makes an absolutely crucial distinction. See, all the AI that we have today is what we call weak AI. Now, don't let the name fool you. It's incredibly powerful, but it's narrow. It's designed for very specific tasks, like being the best in the world at chess, or identifying a face in a photo. Strong AI, the kind you see in sci-fi movies with human-level intelligence that can do anything a person can, that is still completely theoretical. Okay, so how does a machine go from being just a bunch of code to something we'd actually call intelligent? Let's take a look at the learning process. Well, the main way AI gets smart is through something called machine learning. This is the real magic. Instead of a programmer having to write explicit, step-by-step rules for every single possible situation, you give the machine special algorithms. These allow it to learn from huge amounts of data and actually get better over time just by gaining more experience. And if machine learning is the basic idea, deep learning is like the supercharged V8 engine version. It's a much more advanced, much more powerful type of machine learning. It uses a very specific structure to find really complex, subtle patterns in just vast amounts of data. This is the tech that powers the cool stuff like amazing image recognition and all the new conversational AI. So what is that specific structure I just mentioned? Well, it's this: a neural network. And the inspiration for it is right inside our own heads. It's a model designed to mimic the web of neurons in the human brain, processing information through all these interconnected layers to learn in a really sophisticated way. And how do you actually train these networks? Well, there are two main approaches. With supervised learning, you basically give the AI an answer key. You feed it data that's already labeled, like a million pictures of cats, each one labeled cat, so it learns exactly what to look for. But with unsupervised learning, you just dump a ton of data on it and say, figure it out. It has to find all the patterns and structures all on its own. Okay, so let's see how all this stuff, machine learning, deep learning, neural networks, builds up to one of the biggest revolutions in modern AI, the ability to actually understand us, to understand human language. And here it is, the term you've probably heard more than any other: large language model, or LLM. It's a type of deep learning model that has been trained on a truly mind-boggling amount of text. Basically a huge chunk of the internet. And it's this enormous training that lets it understand, summarize, translate, and even generate incredibly human-like text. Under the hood of every LLM, there are kind of three key jobs happening. Think of it like a team. Natural language processing, or NLP, is the librarian. Its job is just to organize all the raw text. Then you have natural language understanding, or NLU. This is the one that actually reads and comprehends the meaning and the intent behind the words. And finally, you have natural language generation,
NLG, which is the author that writes a brand new coherent response.
So, what happened? What made these LLMs suddenly get so incredibly good? The secret sauce was the invention of something called the transformer architecture. This specific type of neural network is just brilliant at processing language because it can weigh the importance of different words in a sentence, no matter how far apart they are. That ability to understand long-range context is the engine that really made models like ChatGPT possible.
But they're not perfect, are they? You've probably heard stories about an AI hallucinating. This is when the model generates an answer that sounds totally plausible, but it's factually wrong or sometimes just completely made up. It's a huge challenge, and it usually happens when the AI gets confused or just doesn't have a real-world understanding of the topic.
All right, let's look at the real cutting edge now, where AI is moving beyond just understanding things and is starting to create new things and even do things for us.
And that brings us to generative AI. This is the broad category of AI that those LLMs we talked about fall into. By learning all the underlying patterns in the mountains of data they're trained on, these models can generate brand new original content, whether that's an email, a song, a piece of computer code, or a stunning digital image. And what's the next evolution? It's something called Agentic AI, and this is a massive leap forward. These are systems designed not just to answer a question, but to autonomously work towards a complex goal. So think of an AI that you can just tell, plan a weekend trip to Paris, and it goes and books the flights, finds a hotel, and makes dinner reservations all on its own. And this right here perfectly sums up the core difference. Generative AI creates something for you. Agentic AI does something for you. It's the shift from having a tool that responds to you to having a partner that acts for you. So, we've covered a lot of ground. How do we actually see these powerful concepts showing up in the tools that we use every single day? Well, a really common application is the AI assistant. You're seeing these pop up everywhere now. It's that chat interface in more and more products, and it uses a large language model to understand what you need and then help you with tasks, like finding a specific document or summarizing a long meeting you missed. But wait, how do you stop that assistant from hallucinating? Remember that problem? Well, a really key technique is something called Retrieval-Augmented Generation, or RAG. This connects the LLM to a trusted external knowledge base. So instead of just guessing from its training data, it first retrieves factual, up-to-date information to give you a much more accurate answer. It's all about grounding the AI in reality. I mean, we've gone from simple definitions to AI that can literally act on its own in just a few minutes. The pace of innovation is just incredible. And it naturally leads to a pretty big question. What does all this mean for the future? And this brings us to our final term, X-risk, which stands for existential risk. This refers to the very serious concern that a superintelligent AI, if it's not designed absolutely perfectly, could pose a major threat to humanity. Maybe not on purpose, but through unintended consequences, or by having goals that just don't align with our own. It's a heavy concept, for sure, but it's a crucial one to think about as we build this powerful technology. It really reminds all of us just how important it is to develop AI safely and responsibly.